Hi, I'm Matt from DeveloPro, and today I'm putting together a short video for everyone that's interested and been calling in and emailing, asking us at DeveloPro for a bit more information on what's happening with these connecting rod failures in the Lamborghini 5-litre Gallardos. It is a problem, and we've been seeing this since around 2003 when the Gallardo came out, right through till now. So a big part of the problem is the OEM connecting rods. These are a powdered rod or a sintered rod. Some people call them a fracture parted rod. You might want to do some of your own research or Google powder rods or sintered rods and find out a little bit more about these. But I guess in short, they're a rod which is formed by compressing a powder or sintered powder to a high temperature and putting it under extreme pressure to force the particles and create a very strong bond. You can get good quality sintered rods. There are a couple of companies in the world that make these, but generally speaking, when these are made in large numbers and punched out, mass produced in big numbers, the quality control, I think, is the issue. So the concept of the type of rod is probably not a bad thing, but the selected use on these rods in the 5-litre V10 Gallardo is probably not the right place for these rods. They weren't initially intended for this engine. They were designed for a smaller 5-cylinder engine which made less horsepower per cylinder than the V10 has, and that's probably what's led. They're just borderline for the engine, which means while everything's going great and everything's fine, the rods are probably okay, but especially in the manuals, not so much the E-gear cars, but the manuals, a wrong selection of gear at the wrong time will create a mechanical over-rev and run the revs up too high, and that's certainly where we're seeing a lot of the failures. But we are seeing failures in the E-gear, just a little bit less common in the E-gear than the manual. So that's the sintered rod. Do a little bit of research. Obviously the conrod bolts in the powder rods aren't as good as the really high grade bolts that we're using in our billet rods that we sell, and the rods we fit to our race engines, which are made in Australia by a company called Argo Engineering, or Argo Rods. We've been using their rods for 5 to 6 years. We've never had a problem with the rods. We run them in our race cars, we run them in our road cars, and we run them in our twin turbo applications in both the 5-litre and the 5.2-litre engines. Here's the billet rod that we use. That's a 5-litre billet connecting rod. When I say billet, it's made out of a piece of billet plate, which is, a lot of people use the term billet and probably don't understand it. And what that means is a billet is generally a forged or compressed hot or cold work piece of material which is very uniform. So if you can imagine a large piece of plate, and these conrods are rough cut, laser cut, or profile cut out of a large piece of billet plate which has a uniform molecular structure and grain structure throughout, and it means that you can cut a full set of rods out of one sheet of plate, and they're all going to be pretty much identical in their structure and their material. It's a lot more expensive way of making a connecting rod for obvious reasons. A lot more machining costs. The material itself is quite expensive, and then we go to the bolts, and the bolts we use are extremely expensive too. In fact, the bolts in these rods that we put in the 5 litres are a large percentage of the cost of the connecting rod, which we'll go into in a later video, but there's probably a full video just on the design of the rod and the conrod bolts and how to fit those. So I'll try and get a little bit of a closer view at the sintered rod for you, because unless you've seen one of these, it's hard to explain. With the sintered rod, when they make this rod, they make the rod in one piece basically. They machine it, and then this has to be in two halves. This has to be fitted to a crankshaft that goes down through the cylinder bore, it goes over the crankshaft conrod journal. This part comes up from underneath. This is the cap. The cap comes up from underneath and it's bolted together on the crankshaft. So it has to be in two parts to be fitted to the engine. Now, with a good quality conrod, this bore is machined, it's then cut in half, and once you cut it in half and put it back together, you don't have a round hole anymore. You've got like an elliptical sort of shape there, so it's got to be put back together, tensioned, the bolts are tensioned, and then it's finish honed to size, and that's a lot more machining processes than is required for the powder rod or the sintered rod. So what do they do with these? They pretty simply, they freeze the rod and they literally snap it like a carrot. It's snapped and sheared in half, and it leaves a very jagged finish, and I'm hoping the camera can pick up the rough edge there. Okay, try and get on the cap. So it does go back together. It means that it goes back together with a perfect fit, but there's no way of reconditioning these rods once they've had a fault or a problem. You can't fix these things. You chuck them in the bin, which is what we do with all the Gallardo rods anyway. As soon as we get an engine in, regardless of whether it's got a rod problem or not, these come out and they go straight in the bin. It's about all they're good for, really. With the billet rods, and most good billet rods, whoever makes them, we don't have a fracture parted big end. We have a nice, smooth, uniform machine finish on both faces. And you can see here we run a perimeter dowel. It's a perimeter dowel pin, and that ensures that the cap goes back on in an identical place to it was when it was finished machined and machine honed. So you can see it's a very, very snug fit. The other thing those dowels do is they prevent the cap from walking and moving about while it's in use, and it keeps the conrod bearings concentric and firm in the rod to stop any sort of movement there, and increases reliability.